Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So in the previous class students, we were started with the exercise problems of class 12, that is relations and functions. We had stopped at the question number 5. So we'll be continuing in this session. Okay, we'll be doing the NCERT questions. So whatever questions we are going to, or I am going to solve on the board here, so these questions are the most important questions. Okay, so the important questions we are solving. The rest of the questions are also important. You can try those questions on your own. All right. So let us begin with the session. Very first question. So this question is from exercise 1.1. In the previous class we stopped at question number 5. Okay. So after 5, 6 and 7 you can try them. Now in this class again question number 8 is the most important. All right. So here exercise 1.1 they're telling question number 8, show that the relation R, the set, so set A is given 1, 2, 3, 4, 5, given by, so students see this is the relation, R is equal to AB such that mod of A minus B is even. Okay, what is mod, students? For example, mod of minus 1 is equal to how much? It will be equal to plus 1. That is the mod function. Mod of A minus B is even is an equivalence relation. So we have to prove that the given relation, show that, right? So we have to prove that. Prove that the given relation is an equivalence relation. Okay, so this is question number 1 until here. Sub question. Continuing, show that all the elements of 1, 3, 5 are related to each other and all the elements of 2, 4 are also related to each other. The second part of the question, we have to show that 1, 3, 5 is related to this equivalence relation as well as 2, 4 is also related to this equivalence relation. Okay, so we'll stop here again. Second sub question. Third sub question, but no element of 1, 3, 5 is related to any element of 2, 4. So we have to also show this. So there are 3 sub questions within this. Understood? So we'll start solving these questions. So we'll do the first sub question first, then come to the second, then come to the third. So first we have to show that it is an equivalence relation. So what is the meaning of equivalence relation, student? So equivalence relation is nothing but a relation which is satisfying reflexive, symmetric and transitive. So a relation which is satisfying these 3 relations are called as an equivalence relation. Okay. So let us start with reflexive. All right. On this side we'll start. Here we'll start with reflexive relation. So how is reflexive relation defined? Okay, we'll see that first, then we'll start proving that it is a reflexive. Okay, so reflexive relation is something like this. A comma A, okay, the ordered pair A comma A such that all elements of A, for all A will write, for all A belongs to A. So whatever elements are present, okay, in the set, if each and every element has a doublet, okay, then we call that relation as a reflexive relation. Okay. So here it is A comma B, right? So reflexive means it must be A comma A, correct? So mod of, okay, this is mod of A minus A. This will be equal to how much, student? 0. So what is this A? A is belonging to set A. What are the elements in set A? 1, 2, 3, 4, 5. So in the place of A, if you put 1, so mod of 1 minus 1 is how much? 0. If you put 2 in the place of A, mod of 2 minus 2 is again 0. So what is 0, students, again? 0 is an even number, correct? So mod of A minus B is even. Here mod of A minus A is 0, which is nothing but even. So therefore we can tell what? The given relation is reflexive. Okay, the given relation is reflexive. Understood? Moving on to the next one. After reflexive, what else we have to prove for an equivalence relation? Yes. So that is, we have to prove that it is symmetric and also as well as transitive. So how is symmetric defined, students? Symmetric relation is defined like this. If A comma B is belonging to R, then B comma A also should be belonging to R. Then only we can tell it as what? It is a symmetric relation. So here what is the relationship given? R is equal to, so R is equal to what is given in the question, students? This we are writing here. Okay, R is equal to A comma B such that mod of A minus B is 1. This is the relation given to us. So it is even, students. Okay. So what should we prove here? A comma B. A comma B. Then B comma is also belonging to set or that relation, right? If we prove that, then we can tell that the given relation is symmetric. Okay. So here what we'll do, mod of, we have to show that mod of A minus B. Okay, what can this be written as? This can also be written like, if you take the minus sign common, it will become B minus A. So mod of minus of B minus A. So this is nothing but what, students? Equal to mod of minus A. This side will be writing A minus B. So if mod of A minus B is equal to what now? B minus A. So what is mod of A minus B? This is nothing but even. B minus A is also even as well. So therefore the relation is symmetric in nature. Okay. Therefore the relation is symmetric in nature. So we have proved reflexive, just now proved symmetric as well. Okay, next we'll be seeing how do we prove transitive relation. Okay. So transitive relation here we'll write. So how is transitive relation defined? The transitive relation is defined as A comma B belonging to R and B comma C also belonging to R. If A comma C is also belonging to R, then we can call that relation as what? Transitive relation. Okay. So A comma B belongs to R, so that is nothing but mod of A minus B, correct? So this will be what, students? Even. Okay. Similarly, B comma C. So it is mod of B minus C. This is also even. So when you add two even numbers, what will you be getting? So mod of A minus B is even. Okay, understand. Mod of B minus C is also even, which implies A minus B is even as well as B minus C is also even. So we are just putting mod to them, but they are even. So when you add two even numbers, what will be our answer? So add them both. So let us take it as number 1. Let us take it as number 2. Add 1 and 2. So it will be A minus B plus B minus C. This will get cancelled, which is equal to A minus C. So when you add two even numbers, for example, add 18. 18 is an even number, right? 18 plus 18 will give us how much? 36. So when we add two even numbers, we'll be getting even number only as a result. So A minus C is also what now, students? Even. So therefore, what can we call this now? We can call this as a equivalence relation. Why? Because this relation is satisfying reflexive, this relation is also satisfying symmetric as well as transitive. So this part of proving is done. So we have shown that the given relation is equivalence relation. Okay, moving on to the next. Show that all the elements of 135 are related to each other. So 135 is related to reflexive, 135 is related to symmetric, 135 is also related to transitive. We have to show this. Okay. And also 2 and 4 are also related to each other. So 2, 4 is related to reflexive, symmetric and transitive as well. But 135 and 2, 4 are not related to each other. How do we do that? So students understand, very simple. 135, all are odd numbers. Okay. So subtract 5 minus 1, 5 minus 3 or 3 minus 1, 5 minus or 3 minus 5. Subtraction between these numbers. Okay. So when you subtract two odd numbers, what is the answer? For example, here only you can see 5 minus 3. What is the answer, students? 2, which is an even number, correct? 3 minus 1 again, even number. So this set is satisfying reflexive because any subtraction between these odd numbers we are getting what? Even. 0, that is even. Here also, students, same thing, symmetric also we are getting even, as well as in transitive also we are getting even, which means 135 is satisfying reflexive, symmetric as well as transitive. Okay, same thing for 2, 4 also. Subtraction between two even numbers. For example, 4 and 4 minus 2 is always even again, 2. So this 2 comma 4 is also satisfying for reflexive, symmetric as well as transitive. Okay, so this is the proof of the second part, whereas now coming to the last part. So from here until here, no element of 135 is related to any element of 2, 4. So if you operate an odd and even number, okay, it will always be odd. So for example, see this, 5 minus 2, how much, students? 3. And what is 3? 3 is odd. What do we want here? We want even, correct? So these both are not related with each other. So hence we have proved all the three things. We have proved it is equivalence. We have proved this is related to all the three. This is also related to all the three, as well as these both are not related with each other. Okay, so this is the entire solution for the given 8th question of exercise 1.1 from your NCERT. I hope you have understood this question. Any doubts, please do comment in the comment section. Moving on to the next question. Okay, question number 9, sub question number 1. So show that each of the relation R in the set A, x belongs to a set of integers such that x is greater than or equal to 0 but lesser than or equal to 12. Okay, given by the relation is given here. R is equal to a comma b such that mod of a minus b is a multiple of 4. So let us see first what are the multiples of 4 here. So 0, 4, 8, 12, 15, 20, 24 and so on. 24. So now let us write set A, students. So how do we write set A now? Set A can be written as 0, 1, 5, 6, 7, 8, 9, 10, 11 and 12, greater than, lesser than or equal to. So we are writing also what, students? 12. Okay. So relation also we'll write down here. So given relation R is equal to a comma b such that mod of a minus b is a multiple of 4. Very similar to the previous example, students. See, in the previous example it is an even number, correct? In this example it is a multiple of 4. So that is also nothing but even. So however we have solved this, in a very similar manner we can solve this as well. Okay. So we'll start with the solution here. So we'll prove what first, students? Okay. We'll prove reflexive first. Okay. So reflexive, how is it defined again? A comma A such that all A belongs to A. Understood? All A belongs to A. So now any number you take, mod of A minus B is a multiple of 4. So how many elements are there in set A, students? So there are these many elements. A comma A for all A belongs to A. So A comma A means how will the relation be defined here? Mod of A minus A will be equal to what? Multiple of 4. Okay. So any number you take, students. For example, you take 6. Okay. Mod of 6 minus 6 is equal to how much? 0. So 0 is what? A multiple of 4. Here. Multiple of 4. 0. Understood? So therefore what we can tell? So mod of A minus A is a multiple of 4 for all A belongs to set A. Okay. Therefore we can tell that the relation R is reflexive. That each of the relation in the set A is given by multiple of 4. So it is here what, students? It is reflexive. Okay, moving on to the next one. Next we'll be proving what? Symmetric. Symmetric, how do we prove it? A comma B belongs to R and B comma A also belongs to R. Then we can call it as what? We can call it as a symmetric relation. So for example, here we will take A comma B again. So it can be written as mod of A minus B. This must be what, students? Multiple of 4. Similarly here for B comma A, what can we write? Mod of B minus A, which is also equal to multiple of 4. Okay. So now let A equals 4. Okay. And B equals 12. What is mod of A minus B now? Mod of A minus B is nothing but mod of 4 minus 12 is equal to 8, which is multiple of 4. Similarly, students, 12 minus 4, this is also equal to 8, which is also multiple of 4. So what can we tell here? Mod of A minus B is equal to mod of, okay, from here take minus sign common. Okay, you will be getting what? B minus A. So mod of any minus quantity will become what, students? Mod of A minus B is equal to mod of B minus A. So both are equal to each other, which means it is a multiple of 4. Therefore the relation is what? Symmetric in nature. Okay, moving on to the next one. We should also prove it as reflexive is done, symmetric is done also. Similarly, students. transitive. Okay, we have to show that it is transitive as well. So how do we define transitive? A comma B belongs to R, B comma C belongs to R, A comma C also belongs to R. So A comma B means what is this? Mod of A minus B is a multiple of 4. Mod of B minus C is multiple of 4, as well as mod of A minus C is also, or it should also be multiple of 4. Okay, so same example only we'll take. Mod of A minus B is how much, students? 8. Here also it is 8, which means what? A minus B is a multiple of 4, as well as B minus C is a multiple of 4. So when you add two multiples of 4, you will get a multiple of 4. So add them both, A minus B plus B minus C. Okay, plus B minus C cancel, you'll be getting A minus C, which is equal to how much? 16, which is also a multiple of 4, correct? So therefore what we can tell? We can tell that the relation is transitive as well. So the relation is satisfying three relations. One is reflexive, symmetric, as well as transitive. Or we can call this relation also as what? An equivalence relation. Moving on to the next question. Same exercise 1.1, question number 12. So that the relation R defined in the set A of all triangles. Relation R is given like this, students. R equals T1 comma T2, where T1 is similar to T2. So previously, students, in the relation, if you observe, okay, previously is a multiple of 4 here, okay, and here it is even. So in the next question, what do we have? We have T1 is similar to T2. Okay, so show that the relation R is defined in the set of all triangles R is equal to T1 comma T2, where T1 is similar to T2. Okay, that is the condition to be satisfied. Is an equivalence relation. So equivalence means what again? We have to prove that it is symmetric, transitive, as well as reflexive. All the three. Consider three right angle triangles. Okay, so T1 is given here. T1 is 3, 4, 5. T2 is 5, 12, and 13. T3 is given as 6, 8, and 10. So which triangles among T1, T2, and T3 are related? Okay. So as soon as you see these numbers, students, 3, 4, 5, 5, 12, 13, and 6, 8, 10. What are these? These are nothing but called as Pythagorean triplets. Pythagorean triplets. What is this Pythagorean triplets? Means it are those numbers with the sides, right? So these sides are representing a right angle triangle. Pythagoras theorem. So what is Pythagoras theorem? Hypotenuse square is equal to sum of side square. For example, see this. Okay, 5 is the hypotenuse. How do we know that? Hypotenuse is the biggest side in a right angle triangle. So which is the biggest side here? 3, 4, or 5? 5 is the biggest side, right? So therefore 5 is what? Hypotenuse. So 5 square is equal to 25, correct? 4 square is 16, 3 square is 9, 16 plus 9 is 25 as well, which means it is what? It is a Pythagorean triplet. Similarly here, students, this is the biggest side, 13. So what is 13 square? 169. So 12 square is 144, 5 square is 25. So 144 plus 25 is again 169, which means it is a right angle triangle satisfying the Pythagoras theorem. Same thing for T3 as well. 6, 8, 10. 10 is the biggest side. So what is 10 square? 100. 8 square, 64. 6 square, 36. Correct? So 64 plus 36 is equal to 100 again, which means it is a right angle triangle. So they're using another word, students, here. Okay, that is called as similar. What is the meaning of the similar? Small example I'll give. Okay. So there are two words, students. When we take triangles, when we are studying triangles, we'll be getting two words. So what are those two words? One is similar and one more is congruent. Okay, what is the difference between similarity and congruency? This you already studied in your 9th class. Quickly revising it once. So for example, similar is nothing but shoes. For example, you can consider school shoes. Okay, school uniform shoes. Okay, it is similar. So you see all the boys' shoes, it will be same. It is similar. Means similar actually means it has the same shape. Okay, shape tick mark, but size into mark. Shape is same, students. The school shoe shape is same, but size is differing, right? It will differ from one kid to another kid. For example, one child the size is 8, another child the size is 9. So this is called as similarity. Shape is same, size is not. What is the meaning of congruent? Shape is also tick mark, size is also tick mark. For example, debit cards. So you take the debit card of any bank, okay? It will fit into any bank, it will fit into any ATM machine, which means what? The debit cards are congruent. What is the meaning of congruent? Same shape and same size. So we'll start proving this. Okay, we'll start with equivalence relation now. So means we have to prove again three relations. So let us start with reflexive again. Okay. Reflexive relation. Reflexive is defined again by A comma A such that for all A belonging to A. So A comma A. So now if you take T1, then again you have to take T1 because A comma A, right? If you take T2, T2 again. If you take T3, T3 again. So first of all, these T1, T2 and T3 with different sides are similar. Why? Because all the three are right angle triangles. So this is triangle number 1, triangle number 2 and triangle number 3. Only the size is increasing but the shape is same. Same shape, size is different. So obviously what will happen here, students? T1 comma T1 is similar. Similarly, T2 comma T2 will also be similar as triangle 2 and triangle 2. Similarly, T3 comma T3 will also be similar. Therefore, what can we tell that? Therefore, the relation R is reflexive. Understood? Okay. We'll go to the next relation. Okay, we'll be proving what? Symmetric as well as transitive. So here we'll write now symmetric relation. So symmetric means what, students? A comma B belongs to R. That means B comma A also should be belonging to R. So now if we have T1 comma T2 belongs to R, correct? See here, T1 comma T2 such that T1 is similar to T2. So here what we can write? T1 is similar to T2. If T1 is similar to T2, then T2 is also similar to T1, right? Correct? So here B comma A is nothing but T2 comma T1 is also belonging to R. It implies that T2 is also similar to T1. Understood? So here what did we prove again? Here we have proved it as symmetric in nature. Okay, moving on to the next relation which is called as transitive. A comma B belongs to R, B comma C belongs to R, A comma C also belongs to R. This is satisfying. We should call that relation as what? Transitive relation. Okay. So T1 comma T2. See this T1 comma T2. 1 comma T2 implies T1 is similar to T2. Correct? T2 comma T1 from symmetric only. So T2 comma T3 will take, not T1. Sorry. Okay, it is T3. T2 comma T3, what can be written here? T2 is similar to T3. Understand? T1 is similar to T2. T2 is similar to T3. Then obviously what, students? T1 comma T3 also exists, right? Which means T1 is similar to T3. Which means what? The given relation is also transitive in nature. Reflexive is done, symmetric is done, transitive in nature. So we have proved three relations: reflexive, symmetric and transitive. So therefore the given relation is what? Equivalence relation. So the last thing, the next sub question under this only. Consider three right angle triangles T1, T2 and T3. Which triangles among T1, T2, T3 are related? So students, by looking only we can tell T1 and T3 are related. How is that? The ratio is similar, students. So T1 is this 3, 4, 5. T3 is 6, 8, 10. See the students, 3 by 6, 4 by 8, 5 by 10. All these are equal to what? 1 by 2. 3 ones are 3 twos are, 4 ones are 4 twos are, 5 ones and 5 twos are. Okay, so this is equal to 1 by 2. Therefore, T1 and T3 are related. Understood? Moving on to the next question. Exercise 1.1, question number 15. Okay, let R be the relation in the set 1, 2, 3, 4. Given by R is also given. Oh, this is an MCQ question. Got it. Okay. Question is a MCQ. Okay, R is equal to, R is given, students. Okay, choose the correct answer. So we have to check whether it is reflexive, symmetric and transitive in nature. Know what is reflexive, symmetric and transitive? We'll just check once. Okay, so how many elements? 1, 2, 3, 4. Doublets are present, you see. For 1, present. 2, present. 3, present. 4, also present. So it is what now? It is symmetric in nature. Put a tick. It is reflexive in nature. Put a tick. Okay. Symmetry will check, students. What is symmetry? A comma B means it also must include B comma A. Okay. So for example, it is having 1 comma 2 means it should also have 2 comma 1. Do we have 2 comma 1 here? Okay, we do not have that, which means it is not symmetric. We'll check for transitive ones. Okay. A comma B, B comma C. What is A comma C? 1 comma 2. Here we have 1 comma 2. Okay. Similarly, this, students. A comma B, B comma C. A comma C do we have? Yeah, we have here only 1 comma 3. So if you check for the other elements as well, okay, transitive will be satisfying. So therefore, how is this relation? The relation is like this. Okay, it is reflexive, it is transitive, but it is not symmetric. So which is the right answer? R is reflexive and symmetric but not transitive, not this. R is reflexive and transitive but not symmetric. This is your right answer. Understood? Moving on to the next question. So next exercise. So that is the end of exercise 1.1. Okay, now we'll start with exercise 1.2. So check the injectivity and surjectivity. What is injectivity, students? 1.1. What is surjectivity? Onto. Okay. Of the following functions, f such that, what is n here, students? Set of natural numbers. How does n start with? N is equal to 1, 2, 3 and goes on like that. Given by f of x is equal to x square. So we have to check whether it is 1, 1. Also we have to check whether it is onto. Okay. Let us take f of x is equal to x square. This is what, students? This is given to us. To check the injectivity, what we'll do here? Okay, we will take f of x1 equals f of x2. What is f of x1? x1 square. What is f of x2? x2 square. Very simple, students. Here we have written x, right? That is why it is x here. Now in the place of x, what are we writing? x1 we are writing. And in the place of x again, what are we writing? x2 we are writing. Why have we written this? F of x1 is equal to x2. This is how you have to start your proof. To prove it, it is 1, 1 function. Always remember this. Put a star mark. So if you want to prove it as a 1, 1 function, start from here. F of x1 is equal to f of x2. Okay. So here we are getting x1 square is equal to x2 square. So below this again we can write x1 equals x2 if you take square root on both the sides, or x1 is equal to minus x2 as well. Correct? x1 equals x2 or x1 is equal to minus of x2. Square on both the sides, you will be getting x1 square is equal to x2. Now this is discarded. Correct? Why is this discarded? Because it is set of natural numbers and there are no negative numbers in natural. So x1 is equal to x2, which means what, students? The relation is 1, 1. Okay, it's not relation, here it is function. The function is 1, 1. F function is 1. Okay, we'll also try to prove onto function. How do we prove onto function? Y is equal to f of x. Okay, so what is y? As it is y. What is f of x, students? X square. What is x then? X will be equal to root of y. Correct? Now let us take y is equal to 3. So then it will become x is equal to root of 3. So this is again not what? Natural numbers. So these are natural numbers 1, 2, 3. Okay, no irrational numbers in natural numbers. So it is not, the function is not onto. So this function given here, this function is 1, 1, but it is not onto. Means it is injective but not surjective in nature. Okay, moving on to the next question. Same exercise 1.2, second question. Here we did sub question number 1. Now we are starting with sub question number. So function, what is z here, students? Set of integers. So how is z defined again? Z is equal to minus 3, minus 2, minus 1, 0, 1, 2, and 3. This is z. Okay, this is our set of integers. Z given by f of x is equal to x square. So again, injective and surjective. So let us start with injective. That is nothing but 1, 1. How do we start it, students? F of x1 is equal to f of x2, which is nothing but equal to x1 square is equal to x2 square, which is nothing but again x1 equals x2 or x1 equals minus x2. Now should we discard this? No, we should not discard this. Why? Because it is set of integers. Previously it was natural number, students. Natural number does not consider any negative numbers. Correct. So but integers consist of negative numbers, but we cannot discard this. But what can we tell here is, we can tell this is not 1, 1 function. Okay, it is not 1, 1 function, or it is not injective function. Why? Because there are no unique images. x1 equals x2, x1 is also equal to minus x2. Understood? If only this is there, then we can tell it as 1, 2. So in the previous slide, you see this got discarded. This was only present. Okay, so we called it as 1, 1. But here what is happening? x1 equals x2 and also x1 is equal to minus x2. Therefore, we cannot, okay, first of all, we cannot discard because it is a set of integers, and we can tell that it is not a 1, 1 function. Going on to the next one. Okay, 1, 1, it is not satisfying. So what is another one? Surjective. Okay, so we'll write here. Surjective, or it is also called as onto function. How do we start this? Y is equal to f of x. What is f of x? X square. Y is equal to, so students, what is x equal to? X equals to root of y. Correct? X is equal to root of y. Now put y is equal to minus 3 because it is a set of integers. Put y is equal to minus 3. So x will be equal to root of minus 3. Okay, what is root of minus 3? Which is equal to 3i. And this is not an integer. Okay, it is what? An imaginary number or a complex number. Correct? So therefore it is not an integer. Therefore we can tell it is also not an onto function, or we can tell it is not surjective. Understood? Moving on to the next question. 1.2. Okay. So 1.2, same question, number 2, but submitting is number 5. So here they are telling function f such that z to z given by f of x is equal to x cube. So we have to check the injectivity as well as surjectivity. We'll start with injectivity only here. Injectivity. That is nothing but 1, 1. Here we'll be starting with surjectivity. Okay. So how do we start with injectivity, students? Start with f of x1 is equal to f of x2. Correct. F of x1 is equal to f of x. Now what is f of x1? F of x1 is nothing but x cube, x1 cube, which is equal to f of x2 is nothing but x2 cube, x2 cube. So if you take cube root on both the sides, okay, cube root of and cube root of this, we'll be getting what? x1 will be equal to x2. That is it. Okay, if you cube a negative number, it is negative only. Okay, previously we had square, students, correct? X square. Here also we had square, x square. But now what do we have? We have a cube. So if you cube a negative number, it will be negative. So only this is existing. So hence we got this. We can tell it as what? It is a 1, 1 function, or it is injective in nature. Understood? So going on with surjective, y is equal to f of x. And what is f of x? X cube. Y is equal to x cube. So x will be equal to what, students? X will be equal to cube root of y. Correct? X will be x cube. Taking cube root on both the sides, we'll be getting x is equal to cube root of y. Okay. So now again put y is equal to 4. So it will become x is equal to cube root of 4. And this is what again, students? It is a rational number. Correct? Cannot be expressed, sorry, irrational number. It is not rational. It is an irrational number. Not be expressed in the form of p by q. What do we have here? Here we have integers, but here we are getting an irrational number. Okay, so therefore we can tell it is not onto. Okay, it is not surjective. 1, 1, yes, onto. Here 1, 1, no, onto also no. previous 1 1s on 2s. This is the second question of exercise 1.2. Okay, moving on to the last question of today's class. Okay, so this will be the last question. After this, we'll be continuing the the exercise problems in our next session. Okay, so let A is equal to 1, 2, 3, B is equal to 4, 5, 6, 7. Let the function is given here, students. F is equal to 1, 4, 2, 5, 3, 6. Be a function from A to B. Show that it is 1, 1. So very simple, students. What you have to do here is we'll map them. Okay, so we'll write all the A elements here. So that is 1, 2, and 3. B elements, we'll write them here. 4, 5, 6, and 7. So we'll just try to map them. So with the help of this, whatever is given, 1, 4, okay, 2, 5, 3, 6. Is this 1, 1? Is this 1, 1? Yes. Why? Because all the elements of the domain has at least one image, the codomain or in the y values. Okay, so therefore it is 1, 1. Is this onto? Onto, no, because this element is left out, right? It is not onto. So 1, 1 means which type of function is this? So this is a function. It is a 1, 1 function. So show that they have told. From this mapping, we can tell that it is a 1, 1 function. So we'll be stopping the class here, students. Please continuing with the next exercise problems in our next class. Till then, like, subscribe, and share with Vistas Learn. Thank you.